Hi, my name is Brandon Graysley. I'm a high school math teacher. Let's learn about periodic functions. Here's the formal definition. A function is periodic if its y values, that's the value of the function, if its y values repeat at regular intervals. That means as you move left or right across the graph, you're going to see the same exact shape repeated over and over again as long as the function on its domain, as long as the function is defined. So a few definitions are going to happen here today. The portion that repeats, if you take that chunk and see it repeated over and over again, the portion that repeats is called a cycle. And that's true for any portion that repeats. So as you see a periodic function, you'll see there are lots of different kinds of cycles that you can see inside of it. And I'm going to call it the width, let's put that in quotes, of a cycle is called the period. So the period is a number, it's like the width horizontally of the cycle. That is the piece that repeats, and because it has a repeating section, we call it periodic. So let's look at an example. And we're going to use an ECG, electrocardiogram, which is like that heartbeat graph. I have one already printed out here that we're going to use. So this section in the center here, this is the function itself. These are my axes, and this is in like millivolts or something like that. This is the electrical energy that's being detected by the ECG. So you can see there's this sort of line here, and then there's a little wee bump, the usual spiky bits, and then a larger bump, and then another horizontal line, before we see exactly the same pattern again. Little bump, the spiky parts, a larger bump, and so on. So what we have here, and you can see these sort of sections, 1, 2, 3, 4 spiky sections, those show us that we have 4 cycles being shown here. So let's just try to cut this up into some sections so that we can notice where the cycles are. So we're not going to use this graph perfectly or anything like that, but let me just notice, here's where like there's a beginning of that first little bump, and there's the beginning of the next little bump. That's sort of the matching part of the graph. So right there, that looks like one cycle to me. So that is a cycle. The width of the cycle, how long this is, like horizontally, that's the period. So for example, if your heart is beating at 60 beats per minute, that would be 1 second of width, because every heartbeat would take 1 second to get you to 60 beats per minute. And so if we go over here, we'll see that there's another cycle right there. And as long as your heart is beating at the same rate, you will continue to get these same, basically the same exact cycles over and over again. So there I've drawn boxes around 3 different cycles, 3 cycles in this. Now, you don't have to, I didn't have to start right there. I could have started somewhere different. For example, we could have drawn from this peak right here to this other peak and called that a cycle. That's a very common way to do it, to look for those highest or lowest points. And we're going to see that again in a minute. So let's look at another example. And this one's going to be height over time. And I want you to imagine that someone is running in a loop up and down a hill. They run down the hill, they turn around, and they run up the hill, and so on. So I'm just going to sketch this graph out. And let's say their lowest height, maybe they start at the bottom of the hill. Their lowest height is here, and they start to run up the hill. So this is height, and this way is time. We're not going to use any units. So near where I live, there's a hill called Second Line, and it's difficult. It's a long, long hill. And so when you run up the hill, you might run up kind of slowly. You get to the top, maybe take a little break, and then you turn around and run down the hill. And I'm running down a little bit faster than I ran up, so you can see that it's steeper on the downward trip. Maybe a little pause before going back up the hill. Now, as long as I can maintain that speed, I'll end up with a nice periodic function, and it just repeats as long as I continue to run. So that is a periodic function as long as your speed isn't really changing significantly, that you're able to repeat the same pace through each section of this. So a cycle might start here and end there, and then the next cycle would end right there, and so on. So a very common example you'll see in math classes is this idea of a Ferris wheel. So I'm just going to write a little couple sentences here, and then we'll work on the problem together. So, and I'll have a picture of a Ferris wheel I'll show you as well in a moment. So a car on a Ferris wheel, this is a ride at an amusement park, something like that. A car on the Ferris wheel starts 2 meters above the ground. And that is at the bottom of the wheel. The maximum height it reaches is 18 meters. It takes 60 seconds to complete a revolution. So a revolution is one time fully around the wheel, from bottom up to the top and back to the bottom again. And so here's our task. Draw a graph that models the height of the car, just that one car, above the ground over time. So height is going to be our dependent variable, that'll be the vertical axis, and time is going to be the horizontal axis because that's the independent variable. So let me show you a picture of a Ferris wheel. So it looks like this. Our car will start at the bottom, and it will revolve around the wheel, let's say in this direction here. So moving in this direction, starts at the bottom, moves up this way to the top, and so on. Now this is the ground. The car starts at a height of 2 meters, and the maximum height it reaches above the ground is up here at 18 meters. Now using that, we can actually figure out that the center must be halfway between 2 and 18. Now the way I work that out is I take the average of these two numbers, so 2 plus 18 is 20, divide that by 2 to get 10. Another option is to say, well, this is a total of 16, so half of that is 8. 2 plus 8 is 10. A couple of different ways to find the middle. In any case, you start at 2, you go up to 18, back down to 2, that's a full revolution, and the halfway point is 10. So I'm going to show you a graph now of what this will look like. See if I can get these both on the screen at the same time. So here at the bottom, that's where the car starts, and it slowly gains altitude here. There's the 10, that's halfway, and then 18 at the top before it comes back down to the bottom again. And then it returns to the top and to the bottom. And this pattern will continue as long as the wheel keeps turning. And so this is a periodic function. You'll go through exactly the same space over and over again. So I want to point out a couple of terms here. I've already mentioned the word peak. And so let's just notice a couple of peaks on this graph. These are peaks right here. P-E-A-K-S, like a mountain peak. And then at the bottom here, we have these other ones called troughs. T-R-O-U-G-H. Troughs. Peaks at the top, troughs at the bottom. And this center area that we mentioned, this 10 meters off the ground. That's exactly halfway between the peaks at the maximum and the troughs at the minimum. That also has a name. That is called the axis. And any periodic function that has both peaks and troughs will always have an axis. So we can use this to, this is what we needed to do for this problem, but we can use this graph now to answer some questions about the movement of this car as it moves around the circle. For example, what will its height be after 45 seconds? Starts down here at 2, up to 18, and it goes back through the middle again, the 10 meter mark at the 45 second mark. So we can use our graph now to answer some questions. So let's define some terms. We just talked about a few of them. Let's write some down though. The axis of a periodic function is the horizontal line that's halfway between, vertically halfway between the maximum and minimum values of the function. And I should maybe write if they exist, because there are periodic functions that don't have a maximum or minimum value. For example, something that goes up forever and then that repeats, goes up forever, has a break in it, goes up forever, that won't have an axis. But anything that kind of looks anything like this, that has a top and a bottom, that will have an axis as well. And in general, if we do have those maximum values, the axis is this, the maximum value plus the minimum value, all divided by 2, and you'll see that that is basically the average of the max and the min. Okay, and another term, the amplitude of a periodic function is the vertical distance from the axis, if it exists, to a peak, that's a maximum, or to a trough. Because it's a distance, that's always going to be a positive number, never a negative number. So even if you're measuring down to a trough, that's not negative. So in general, the amplitude is the maximum value minus the minimum value divided by 2. Because max is greater than min, this will always be a positive number. Okay, now let's talk about another measurement of a periodic function, that is the period, the width of a cycle. So maybe a quick definition or statement here. The period is the difference in x values between two corresponding points in consecutive or adjacent cycles. Okay, let's look at an example for this again. So here I have a pretty wacky looking periodic function. This continues in both directions, and we want to figure out what is the period. So if you pause for a moment, take a look at this to make sure you understand the parts that are repeating. So a good strategy is to identify a point that you can find the x and y value of reliably based on your graph, and then find that same matching point in a consecutive cycle, in the one before it or the one after it. So I'm going to notice right here I have a peak. And the next peak is right over here. This was not a peak because it's lower. This is another peak. And if I look at the graph, it appears to be the same shape from there. So there is another cycle. And let me just check over here. I should see another one. I do. I'm just counting. That's 6 away. That's 6 away. And there's another one over here as well. So you can just measure this distance here. Measure, not with a ruler, but by reading the graph's scale. And we can just subtract the x values. Or in our case, we can just count because it's not that difficult on here. But in this case, let's see, this has a, let's see, that's 8. X value is 8, and the x value is 2. And we can subtract to find that the period is only 6. And the same thing could have been done over here. This is 14. Subtract 8 to find 6 again. You can do this with any matching point. So maybe I'll look at this point right here. That point and that point match. That's 6. That's at 12. The difference is 6. That one's at 0. If you can find the one that matches what 0 is, the height at 0 here, the y value at 0, that's nice because it's always just that x value. Sometimes this isn't a really nice point if it doesn't go through a really nice y-intercept, so you might find some other points. You can also use troughs, and you'll notice in this graph, this trough here matches this trough over here. But be careful not to choose this one. These are 2 troughs, yeah? And these are also 2 troughs. This has many troughs, but you have to watch that you're getting some that match. So be careful that you're choosing 2 matching ones. All right, next, let's look at some non-examples, things that are not periodic functions. So here we have what looks like a parabola. This is not periodic because it does not repeat. If I move over to the right here, I don't find another loop like this, and same with on the left. This is a smooth curve, but it's not periodic. This one over here looks like it has some repetition to it. Up, down, up, down, and so on. Looks kind of like our Ferris wheel example. But you can see that these are not all exactly the same as each other. This seems to be getting smaller or closer to the x-axis. So this is not periodic because it's not repeating, even though it is predictable. This is more promising looking. Up, down a bit, up, down a bit, up, down a bit. So there's a pattern here that is repetitive, but because the y values are not exactly the same, it is sort of rising as we move up here. This is not periodic either. So yes, there is a pattern to it, but the y values are not repeating. So it's not periodic. And the last one here, this is a circle. Well, first of all, this is not a function at all. Circles are not functions because they fail the vertical line test. But a lot of people think about this as periodic because it goes, around and around. They see that circular repetitive pattern to it. But no, if you go from left to right only, we have, if you want to even just look at half of it, goes up, down, and then there's no repetition on either side here. There are no repeated cycles. So this is not a periodic function either. Now sometimes functions are not defined with equations or even with those smooth curve graphs. Sometimes they're defined using just tables of values. So this table of values might look a little unusual to you. You see x is on the top here, y is on the bottom. Usually we have columns, a column of x and then a column of y. But with periodic functions, because they move left and right so far, we end up kind of transposing or flipping this so that all of the x values are on the top and all the y values are on the bottom. Each of these corresponds to a point. That's the point 0, 2, 2, 1, 4, -1, and so on. So we're going to graph this to see if it is periodic, and then we'll look back at the table and do some thinking about it. So first, let me just draw some axes here, make them really clear. That's my y-axis, and my x-axis is here. And I'll put a quick scale in. There's 5, 10, 15, and 20. And I'm just going to look at my y values. They go from 2 is the maximum and -1 is the minimum. So let's call that 2, 1, and there's -1, -2. Okay, let me change colors to start plotting these points. Now this is not a smooth curve. This is just a long series of points. You can imagine it might be measurements made over the course of a number of days, something like that. At x value 0, we have a y value of 2. We have 2, 1. 4, -1. 6, 0. 8, 2. 10, 1. 12, -1. Hopefully you're seeing this pattern now. And I can't quite fit that one on my graph. Should have started over a little bit. And there is the pattern. Now this is a periodic function because the pattern does repeat. Now I see some peaks here. There's a peak at 0, and there's another peak at 8. If I look another 8 to the right, I should see a peak. There's 16, there's another peak. It looks like this has a period of 8. Looking at the troughs, there's a 4. 8 more than that would be 12. There's another trough at 12. And 8 more would be 20. There's 20. So we're getting peaks and troughs at the right places. We can also check our x-intercepts. There's 6. 8 more than that would be 14. Cool. And after that we should get 22. And that's the one we had a trouble fitting onto our graph. You can see all of this inside of the table itself as well if you look for maximum and minimum values. So this is a max, and here's a max, and here's a max. Now that's no guarantee that those are a full period apart. As we saw in that earlier example, sometimes there's more than one maximum or more than one minimum. But it's a good starting place. And here we see another one, the minimum, and the minimum. So yes, from our graph we see that it's periodic. Let's identify a few of the features of this then. So first of all, we found that the period was, what did we say it was? It was 8. Well, let's talk about the amplitude then. The amplitude is half of the difference from the top to the bottom. So maximum minus minimum divided by 2. The max is 2, the minimum is -1, and let's divide that by 2. So the amplitude is 2 minus -1 divided by 2. That's the same as 3/2 or 1.5. That's the amplitude. Let's find the axis. The axis is y equals the maximum plus the minimum divided by 2. Maximum plus the minimum divided by 2. That will be 1/2 or 0.5. That's the axis. And maybe I'll sketch that onto the graph for us. So a horizontal line at y equals 1/2. And that is the axis right there. It's halfway between the top and the bottom. So the key things to know right now are that periodic functions repeat as you move left or right on their domain. The peaks are the tops, the troughs are the bottoms. The period is the width of a cycle, the chunks that repeat. The amplitude is the distance from the axis to the top or the axis to the bottom. That's sort of half of the height of the whole function. And the axis is that horizontal line that's right in the middle. And also don't forget that the amplitude and the axis don't exist if the function goes up to or down to infinity or negative infinity. It only works if it has peaks and troughs. That's when you get amplitude and axes. Okay, let me know if you have any questions. Thanks.